Hello students, welcome to Eduxcite classes. My name is Monit and in today's session we will continue from the last video, A.2 forces and momentum. In this particular video we are basically discussing about the conservation of momentum. If you have not watched my previous video, please check the playlist. The link is given in the description. Okay. So this is my website where you can find out the PDF of this video as well as the marking scheme. You can just download it, is free of cost. And please share this video as much as you can so that it reaches to the masses. And if you have any doubt or you want any one-to-one session with me, please scan the QR code. You can chat with me. Please avoid the odd hours. Okay. So this is the formula that are given in your data booklet. You can check. Please carry a data booklet and a calculator with you. If you are solving with me with this video, I will give you time to pause and you can solve it right there and you can check with me. Okay, these are some important points that you have to remember for this particular topic, conservation of momentum. Sometimes they may ask you for 1 or 2 mark question to state the principle of conservation of momentum. So in this is the most important part. If you the total momentum of any system, it can be 2 balls colliding or it can be an explosion, anything is constant provided there is no external force acting on it. If you have not mentioned no external force, then you will not get the marks. You just write down if the momentum before the collision is equals to the momentum after collision, and if you have not mentioned there should be no resultant force acting on the system, then you will lose your mark. This is very, very important. Many students missed out these things while writing down the answer. And during elastic collision, total kinetic energy is conserved before the collision and after the collision, they should be same. Whereas in inelastic collision, the kinetic energy is not conserved, it lost during the collision. So these are 2 different types of collision in our syllabus. Okay. Also, conservation of momentum is applicable in either it is an elastic or inelastic. So if a question is asking you to compare whether it is elastic or inelastic, so you should not compare the momentum, you should compare their kinetic energies. Okay. So this is just a quick recap. Now getting into the solving the questions, please pause the video and solve question number 1. Okay, so here you can see there are 2 masses of one is of 6 kg. Let us say this is of 6 kg and it is moving at a speed of 14 meter per second and it collides head on with a stationary mass of 8 kg. Let us say this is 8 kg and the lighter mass rebounds. So this is the before collision condition and this is the after collision condition. Okay, so let us say this is positive 14, that is u1, u2 is 0 and this is 6 kg and this is 8 kg. Similarly, after the collision it rebounds with a speed of, rebounds means it moves in the opposite direction, so this will be minus 2 meter per second and this we don't know, so we will say this is v2, this is v1. Okay, so these are the nomenclatures for the speed and the masses. Now we have to say that is this collision elastic or not. So as I mentioned, elastic collision is the one where the kinetic energy is conserved. So before that we should know the velocity of the ball after the collision, that is v2. So applying, you can say applying principle of conservation of momentum, which is nothing but momentum before collision is equals to momentum after collision. So I am just writing 6 times 14 plus 0 is equals to 6 times minus 2 plus 8 times of v2. I hope this is quite clear. So this you solve. So this you solve, you will get v2 something around, I have already done the calculation, which is equals to 12 meter per second. So this is v2. Now we have to compare whether it is elastic or inelastic, right? So I can say kinetic energy before collision is half times mass times 14 square, right? Now if you solve for this, you will get something around 588 joule, and kinetic energy after collision, it is half mass of 6 times minus 2 square is 2 square, this plus half times 8 times speed we have already calculated 12 square. So if you do this you will also get 588 joule, right? Now you can say as kinetic energy before collision is equals to kinetic energy after collision, therefore it is an elastic collision. So if it is not coming equal, then we will say it is an inelastic collision. Okay, so I hope the question number 1 is quite clear to you. If you have any doubt, just comment below. Okay, now pause the video for question number 2 and solve. Okay, now if you look at this question, this was mass m, this is m by 4, and let us say this is 3m by 4, right? Now the energy released in the breakup, when they just break up apart, is energy is q. What is the kinetic energy carried by the lighter piece? So in terms of q we have to find out, right? So initial momentum or momentum before the explosion is 0 because it is at rest, and therefore the momentum after the collision should also be 0. So they both pieces will move in such a manner that the sum of their momentum will be equal to 0, right? So can I say if this is p, this will be minus p? Because otherwise how it can be 0, right? So let us say this momentum of m by 4 is p, I am taking the magnitude, and this will also be p. And one important thing you have to remember, guys, whenever the question is related to kinetic energy and momentum, you always remember this equation: kinetic energy is p square upon 2m. I think this is also given in your data booklet, you can check. P is the momentum, m is the mass. So we have to find out the kinetic energy carried by the lighter piece, right? So what we can do is kinetic energy of the lighter piece over the kinetic energy of heavier piece. So this will be p square upon 2 times of m by 4 divided by p square upon 2 times of 3m by 4. Now if you look here, p square is equal, 2 is equal, m is equal, right? So if you further simplify this equation, it will be 1 by 4 times 3, it will be 1 by 1 by 4. So it will be 1 upon 1 by 4 times 1 upon 3 by 4. So if you solve for this, you will get, this will become 4 and this will become 4 by 3. So it will be here. So this gets, we get the fraction as 3. So the kinetic energy carried by the lighter piece will be the, you can say 3 times of that of the kinetic energy of the heavier. Kinetic energy of the lighter will be 3 times the kinetic energy of the heavier particle. Okay, and the total energy, the kinetic energy of lighter plus the kinetic energy of the heavier is equals to q. So we can say that the kinetic energy of the lighter is 3 times of that of, or you can say this I can write as kinetic energy of heavier particle is 1 by 3 times of the kinetic energy of the lighter. So I'm using this here. So kinetic energy of heavier, so this is kinetic energy of lighter plus 1 by 3 times of kinetic energy of lighter is equals to q. So you can solve this kinetic, so 1 plus 1 by 3 is 4 by 3 times of kinetic energy of lighter is equals to q. So you can say kinetic energy lighter is equals to 3q by 4. So this will be your answer for question number 2. I hope it is quite clear. Just it's a simple calculation. This is the most important equation for this momentum and relation between the kinetic energy. So please remember this and just use the equation. Pause the video if you have not understood the calculation. I tried my level best. Okay, now pause the video for question number 3 and solve. Okay, now the A part, if you look here, the mass of 2 kg, let's say this is mass of 2 kg and it is sliding on a ice surface with a speed of 6 meter per second. Now the object explode into two pieces of 0.5 and 1.5, right? After the explosion, the smaller piece stops relative to the ice. Now this is 0. We have to calculate the speed with which the heavier or the larger piece move after the explosion. So just applying the principle of conservation of momentum. So I can say momentum before collision should be equals to momentum after collision, as there is no external force acting. So the mass 2 into times 6 plus there is no other particles, so and after explosion it is equals to the 0.5 becomes at rest, so it will be 1.5 times of V, right? So if you solve for this, you will get this will be 3 by 2, so this will be 2, so 2 times 3 is 8 meter per second. So this will be your answer for the question number A part. Now the B part, the gain in kinetic energy of the system as a result of the explosion. Now the gain in kinetic energy of the system as a result of explosion will be I can say kinetic energy gain will be equals to kinetic energy final minus kinetic energy initial. So final is half 1.5 into 8 square minus, this is the final because the other mass is at rest, so there is no kinetic energy in that 0.5, whereas kinetic energy final is half time mass time 6 square. Now if you solve for this, I have already done the calculation, it will be 12 joule. So the answer will be 12, and this 12 joule is coming from the energy that is there in the system before the explosion. So if the explosion is there, it might be because of some chemical energy stored in it, okay, in the form of chemical energy. So I think question number 3 is quite easy. Now this is a very good question. Pause the video and solve question number 4. Okay, so if you have understood the question, this is the rocket, okay, whose mass including the fuel is 5000 kg. It is desired to give an average acceleration of 15 meter per second square during the first second of firing the engine. So as soon as the engine is fired, the initial acceleration will be 15 meter per second square. Now the gases that are leaving the rocket are at a speed of 1500 meter per second in this direction relative to the rocket. Estimate how much fuel must be burned in that particular second in order to give that acceleration to the rocket. So in that case, what we can do is we can say that momentum before collision is 0, so the momentum after the collision should also be equals to 0. This should be equals to 0 because initially they were just having, and once it is the engine is start, then it is moving. So before the collision it is 0, so after collision it should also be equals to 0. So what we can say is before the collision I can say m mass of the fuel is ejected out. So the momentum after the engine gets start, this will be 5000 minus m times the speed of the rocket v in that particular second minus, this is the speed of the rocket, okay, it is moving with the speed v. So this is the momentum of the rocket that and minus because that is the fuel which has been emitted out is in the opposite direction, or you can say plus momentum, the mass m of the fuel is ejected out. This will be 1500 minus v, because this is relative to the rocket. So relative to the rocket, so the speed with which it moves out will be 1500 minus v, and this will be equals to 0. Okay, so now we know that the average acceleration is 15 meter per second. So in the first second, I can say, because we have to find out the fuel which must be burned in that particular initial 1 second. So in the first second, I can say the velocity will be v equals to u plus at. U is 0, acceleration is 15, times t is 1. So this will be 15 meter per second. So I place the value of v as 15 meter per second in this equation. So I got 5000 minus m times 15 plus m times 1500 minus 15 equals to 0. Now when you solve this, you will get the value of mass something around 50 kg in 1 second. So you have to, or you can say the fuel that will be burned during that second to provide the average acceleration of 15 meter per second is 50 kg. So I hope you have understood this equation. This is the relative speed of the fuel with respect to the rocket. Gas is leaving the speed with 1500 minus v. So this is already 1500, but the relative to the rocket. So 1500 minus v will be the speed with which the gas leaves. Okay. Try to go through this equation once again if you have not understood, or you can comment below. Now pause the video for question number 5 and solve. Okay, so these collisions, when they are in 2 dimensions, this is only for HL students only. It is mentioned in your guide that the collisions in 2 dimensions, the momentum of conservation of principle in 2 dimensions is only for HL student. So let us start solving for the A part. Determine the speed u1 and v1 of the first puck before and after the collision. So here we have to just apply the conservation of momentum in the x direction before collision with respect to the moment of collision in x direction after the collision. Similarly, the momentum from collision in vertical, that is y direction, before collision should be equals to the momentum of the particles in vertical direction after the collision. So the principle of conservation remains the same, only we are dividing them into the vertical and the horizontal component as we generally do in our forces as well. So the same concept will be required. So I am applying the conservation in horizontal first. So in horizontal, momentum is 0.2 times u1, and initially this is at stationary, so this will be 0 will be equals to 0.2 times v1 cos of 37. Because this is 37, the velocity component in horizontal will be v1 cos 37. So this will be plus 0.3 times 0.5 cos 45. Now if you solve for this, you will get a relation between u1 and v1. Okay, in vertical I can say it initially the vertical component is 0, so I can say this will be 0, or in other word I can also rewrite the equation directly that this momentum in the upward direction should be equals to the momentum in the downward direction. So 0.2 times v1 sine 37 will be equals to 0.3 times 0.5 sine of 45. So here you solve for v1 is nearly coming to as 0.8812, or you can say v1 is equals to 0.88 meter per second. Now I will use the value of V1 in the horizontal equation 1. So using V1 in equation 1, I get U1, you can put up the values, you will get something around 1.234, or I can say this will be equals to 1.234, or I can say 1.2 meter per second. So these are my answer for the part A. Now calculate the percentage change in the kinetic energy of the system. So for the B part, what I can do is percentage change. So you just find out the kinetic energy before the collision, after the collision. So kinetic energy after collision upon kinetic energy before collision times 100 will be the answer for this. So you can directly do kinetic energy after the collision. It is 0. So after collision, change in what we have to find is percentage change is wait, this will be kinetic energy after collision minus kinetic energy before collision upon the before collision times 100. So if you do this after collision, it is 0.1 0.115, and before the collision is 0.152. We are taking the mod because this is the loss in energy upon 0.152 times 100. So I think this is nearly about, you can calculate 0.115 times 152 divided 0.152 times 100, 24.34, or you can say 24%. So this is the answer for your B part. You can do the calculation. So this will be your answer. And kinetic energy after collision, again you can use half m v1 square and u1 square. I have not done that. You can do it. Okay. Now again question number 6 is for HL students only. Again this is quite similar. Here we have to find out the velocity and theta with respect to the ball for the blue one. Okay, so pause the video and solve. Okay, now similarly as we discussed in the previous question, you might have found out I am directly writing now in the x direction. I can say it is 8 mass, we can consider m because they both are of same mass. So m times 8 will be equals to m times 4 cos 60 plus m times v cos theta. So m gets cancelled, so 8 is equals to 4 cos 60 plus v cos theta. So this will be my equation 1. And y direction, similarly I can make, you can say that this momentum will be equals to this momentum. So m4 sine 60 is equals to mv sine theta. So m and m again gets cancelled, so we get 4 sine 60 as v sine theta. So this is my equation 2. Now what I can do is dividing equation 2 by equation 1. So v sine theta over v cos theta is 4 sine 60 over 8, right? So v to v gets cancelled, so we get tan theta as 4 sine 60 up by 8. So theta is equals to tan inverse of this. When you put up the values, you will get the answers near about 30 degrees. Okay, now when we put theta 30 degree in equation 1 or 2, so putting theta as 30 degree in equation 2, we got v as 6.9 meter per second. Yeah. So I hope you got the right answer. If you have any doubt, just comment below. So this is all for your conservation of momentum for paper 2. Now let us discuss few basic and good multiple choice questions for paper 1. Pause the video for question number 1 and solve. Yeah, so option is D, it's quite easy. So the identical block means they both have the same mass, so you can say m times 2 plus of m times minus 3. So after the collision they say that stick together, so always remember whenever they stick together the mass gets added, so it will be 2m times v, right? So this will be minus 1, gets cancelled, is equals to 2 times v, so v will be minus 1 by 2, which is equals to 0.5 meter per second. Okay, quite easy. Try question number 2, pause the video and solve. Okay, so momentum will be conserved, so this momentum is 12, so this has to be 12, so for that the speed for this should be 6, right? Now the energy stored will be the energy of particle 1 and the particle 2, the mass 1 and the mass 2 blocks. So the total kinetic energy is half 3 into 4 square plus half into 2 into 6 square. So this you will get 16, and this is 3 kg and this is 3 kg. So this will be 16, 8, 3, 24, and this will be 36. So this will be 60 joules. So option D is the right answer. Okay. So now we have done these type of question in my previous video. Please check if you have not seen. There are very good questions related to the propulsions, how the change in the mass causes the change in the momentum, and all those types of questions, impulse related, right? So try the question number 3, pause the video and solve. Okay, so the horizontal force, will be mass times acceleration. So mass can be written as density into volume, and volume will be area of cross section into speed v, right? And so this can be written as density into A into v. This is the volume, this is volume, and volume can be written as area of cross section into speed v. Now acceleration, you can say the force that must be exerted, so, or you can say this will be delta m, delta p over delta t, which is delta m over delta t into v, right? And delta m over delta t is density into volume in 1 second. This is volume, so volume is area of cross section into velocity. So this is basically the delta m over delta t, and this this volume is equals to area of cross section to speed v, and this times v gets rho a v square. So option B is the right answer. Okay, so make sure that you know how to solve this. And one more way, using the dimensional analysis also you can solve. We know that force is kg meter per second square, right? The unit for the force, if we do it in the fundamental unit, it will be kg meter per second square, right? For mass into acceleration. Similarly, if you solve for the density is mass per unit volume, kg per meter cube, into area of cross section is meter square, and velocity is meter per second. So it will be square, so meter square upon second. So now you solve this, meter square and this gets cancelled, so you get kg meter per second square. Rest all other units are not appropriate for the forces. So this is also one of the way in which you can compare the dimensionals or the units of the particular quantity which you are supposed to measure, which you are supposed to calculate. So this is the only option which gives us the unit similar to that of the force. Okay, so option B is the right answer. Now pause the video and solve for question number 4. Now this is a very good question, guys. Why? Option is C. Now look at why. Because it is with respect to distance d, guys, not with respect to time. So we know that momentum is mass times velocity, right? Now velocity, we know that if it is a uniform acceleration, we can write v square equals to u square plus 2a d. Let us say the displacement is d, distance is d, because it is moving in a straight line, so distance and displacement will be the same, and it is starting from rest, so this will be equals to 0. So can I write v as under root of 2 times a into d? So if I put this into this equation, p is equals to m into 2 times a into d. Now mass, acceleration, both are constant, so momentum is directly proportional to root times of d, right? Now root times of d is directly proportional, so if it was root d, then this was option is correct, but here it is proportional to root times of d, and for that option C is the right answer, guys. This is a parabolic equation. That means p is proportional to d square, so if it is root d, then this will be like this, or you can say that root graphs are like this only. Okay, so option C is the right answer for question number 4. Now try question number 5. Pause the video and solve. Okay, yeah, so option is B. Why? So you can say that the area under the graph will be, so this is F times delta T is change in momentum, right? And change in momentum is 6 Newton per second. So I can say half, base is 3, height, let us assume this as x. So this is x, or let us say any force F, let us say. So half base into F is equals to 6. So this will be, F will be equals to 4, and now F is equals to ma. So 4 is equals to mass is 2, acceleration is a, so it will be 2. So option B is the right answer. So just read the question carefully, what are the information given, and then you can solve. Now solve question number 6. Pause the video and solve. Okay, so let us say this is block X and this is block Y. Now if this is initially having a momentum mu, now if this gets stopped and this start to move, right? So this momentum of Y should be equals to momentum of X. So this should also be equals to mu. So option B is the right answer. Simple. Okay. Now try question number 7. Pause the video and solve. Yeah, so the option for 7 is C. How? Look here, original kinetic energy lost. Lost means initial will be greater than final. So initial, again I am using p square upon 2m, because the momentum has to be conserved, right? So momentum before the collision should be equals to momentum after the collision, and the momentum of x will be equals to momentum of y, because x comes to rest after the collision. So p square upon 2m minus p square upon capital 2m divided by p square upon what fraction, right? So initial is 2m. Now this gets cancelled, so this equation now is 1 by small m minus 1 by capital M upon 1 by small m. So this will be m minus small m upon capital M into small m into m. So this will get cancelled. So you will get capital M minus small m upon capital M. Option C is the right answer. You have to be very frequent in your calculations. So option C is the right answer. Now try question number 8. Pause the video and solve. Okay, so two objects, let us say this is mass m and this is mass 2m, is traveling in opposite direction with the same speed. So this is v, this is minus v. So they both collide and stick together. What is the kinetic energy lost in the collision? So what I can say is the kinetic energy lost, first we have to find out the speed after the collision. So they stick together, but what should be their collision? So mv minus 2 mv is equals to stick together, so 3 m into v dash. So this will be minus mv 3 m v dash. So m and m gets cancelled, so minus v by 3 is equals to v dash. So the new speed will be in this direction with the 1/3 of the initial speed v, right? Now lost is means kinetic energy lost. Lost means initial minus final. So lost in the collision will be kinetic energy final minus kinetic energy initial. So half into 3m into v by 3 square minus half into half into m into v square plus half into m 2m into v square. So this will be equals to half times 3m times v square by 9, and this will be 2mv square, and mv square will be half into 3mv square. So 3mv square by 2, if I take common, it will be 1 by 9 minus 1. So this will be equal to 9 minus 8 by 9. Because it is lost, so it is coming in negative, so that's not a problem here. So this will be 3 by 2 mv square. So this is 4 and this is 3, so 4 by 3 mv square. So this is option D is the right answer. Okay, now calculation I have done here, no worries. This is for HL students only. Try pause the video and solve. Yeah, so option D is the right answer. So this is like, if this is theta, this will be 90 minus theta, right? So can I say u sine theta is equals to v sine 90 minus theta? If I take the vertical component, the momentum in this direction will be equals to momentum in this direction. So u sine theta will be equals to v sine of 90 minus theta, and 90 minus theta is nothing but how much? Cos theta, right? So this I can say u sine theta is equals to v cos theta. So this is the one equation I can say. Okay, so I can also write u by or v by u as tan theta. So this will be my first thing. I can say v by u is equals to tan theta. So if I use this equation, let us assume these are true. So if I do v by u, so w sine theta over u is w cos theta is coming as tan theta. So w and w get, so it means that this is true, this is true. So first and second are true. So you can see that first and second, so either option A can be there or option D. Now let us see about the third. Third means the W, or you can say the collision elastic. So I can say W, I can say like if yeah, so if it is elastic, I can say kinetic energy is equal, right? So half m W square is equals to half m U square plus half m V square. Half m gets cancelled, so W square equals to U square plus V square. Now if I got this equation, if I fulfill it correct, then I can say this is elastic. So now using the values of U and W in this equation, so U is W cos theta square plus V is W sin theta square. Now you open the bracket, you will get W cos square theta plus W sin square theta. W square is common and sine square theta plus cos square theta is nothing but equals to 1. So it is coming equal to W square. It means that this is an elastic collision. So all statement 1, 2 and 3 all are correct. So option D will be your final answer. So this is the way. Sometimes you have to assume they are correct or not, and accordingly you have to solve. Okay, I hope I have tried. This is for HL students only. So if you like this, just share it with others, and if you have any doubt, just comment below. Okay, now the last question of the day, question number 10. Read, pause and solve the video. Pause and solve the question. Okay, so let us say that the mass m moves with velocity v1 and the another mass will move with velocity v2. Because the momentum has to be conserved, initially it was 0, after it also be 0, so they will both move in opposite direction like this. So m and m gets cancelled, so I get a relation between v1 and v2 as v1 is equals to twice of v2. Now we have to do the ratio of kinetic energy of, so half m v1 square upon half into 2m into v2 square. So v1 I can write half and half gets cancelled, m and m gets cancelled. So I can v1 square upon v1 can be written as 4v2 square, because it's a square upon 2 times of v2 square. v2 square and v2 square get cancelled, so this is 4 by 2, which is 2. So option C is the right answer. So guys, I have tried my level best to discuss all the questions related to the principle of conservation of momentum in 1 dimension, as well as the HL part, which is the 2 dimensions. I hope you like this video. If you like this video, please share with your friends and the classmate, and if you have any doubt, just scan the QR code. You can download the PDF as well. Okay, so keep learning with me. See you in the next video. Bye bye.